Okay, so now we're into a bit trickier territory, but it's stuff that we've done already. We're just sort of converting a couple of bits of knowledge into something new. So to sketch a graph by completing the square, it's effectively when we've already got a quadratic in ax squared plus bx plus c form. So if we look at the example here, so I'll just highlight this one. So we've got a fairly straightforward quadratic, which is x squared take 6x plus 7. Now, it's not one that I can immediately see a sum and product for, and I'm fairly sure based on the graph alongside that I am not alone in not being able to find that. Um, it's the simple case because a is equal to 1, so we don't have to do any dividing through. But what we do need to do is to complete the square, but we do it all on the same side. So as you can see by the little cheat sheet on the left, notice that the plus 3 squared is turning the x squared take 6x into a perfect square, which is x take 3 squared, because we've got this little guy here, which came from negative 3 on 2 squared, which turns into 9, and then we can reduce that back down to find this. Because we're doing it on the same side of the equal sign, we need to make that balanced. So we need to actually subtract that same number, which was 9. We've just made it 3 squared. And that gives us our vertical translation effectively. So from that, the vertex is at 3 and negative 2. On the right-hand side, it's showing those transformations. So you can see that we've taken the regular y equals x squared, and then we've moved it to the right by 3 and down by 2. And that is going to give us this here, which when you look at it, it does not give you any of those details. That is why you need to complete the square to do so. So let's have a look at this example here. Again, I'll highlight it. We have y equals x squared plus 4x plus 3. Now, this is one that we can use sum and product with. However, this also makes it a really good opportunity to use completing the square because it is one that we know what coordinates we should get for our x intercepts. So if you have a look at this, x squared plus 4x plus 3, we know that we can add 3 and 1 to get 4, and 3 times 1 is positive 3. So effectively, it's all done for us, but we are more interested in the vertex here. So let's convert it. We've got y equals x squared plus 4x. I'm going to leave a gap here, and then I'm going to say plus 3. The reason I'm leaving that gap is so that we can complete the square super clearly in between. So when we look at this 4x, we know that for our final term of a perfect square, we need to take 4 divided by 2, and then we square it. So 4 divided by 2 is just 2 squared. Leave it in the brackets just in case. So down here we can now add 2 squared, and then we subtract 2 squared. Because it's on the same side of the equal sign, we need to make sure that that is in balance. Now, if I draw this here to indicate that that is all going together, and I draw this here to show that that is all going together, we can turn this into x plus 2 squared, subtract 1, because 3 take 4 is equal to negative 1. If you get confused about what you have done with that perfect square, the best way to check if you got it right is to just re-expand it out and just make sure it's all good. So from that, let's have a look at some of the other details involved. We know that A is positive, so that is going to be a nice smiley face. We know that the vertex is going to exist at the point where, if I write this in a different one, x take h squared plus k. So h equals negative 2, k equals negative 1. So we have vertex at -2, -1. Let's draw our nice graph. And we're only going to do this based on the information we have. But what you'll notice is that it's pretty close to the intercepts that I mentioned earlier. So vertex at -2, -1. We know that that's our axis of symmetry. And we know that it is a smiley face. We could find the y-intercept as well if we wanted to. So let's actually do that. Y-int at x equals 0, which will be at y equals 0 plus 2 squared take 1. So 4 take 1, which is 3. So let's draw in 1, 2, 3. And bingo, we've got a pretty good representation. So we said earlier that looking at our original function, we could see that we would have 3 and 1 as our sort of sum and product. And we've got -1 and -3 approximately, which sort of satisfies that. So make sure we write in our vertex as well. And that is absolutely everything you need for that one. We'll do a trickier one now. So we need to convert y equals 3x squared take 4x plus 1 into the form of y equals a x take h squared plus k. So converting it to vertex form. And then it wants us to write down the coordinates of the vertex and sketch it. So basically everything we just did. First thing we need to do is we are going to take our y equals 3x take 4x plus 1, and we are going to group that by taking a factor of 3 out and then leaving behind that fraction such that it would all come out in the wash once we times these through together. Now we need to do that because we can only deal with this form inside in order to convert it. Now I will preface that this is a very tricky question. This is definitely up there with your A-level questions. But what we're going to do is deal with the sort of mini quadratic inside. And then this value out the front is just going to be our A coefficient eventually once everything sort of comes out at the end. So let's look at this quadratic in the middle as if it is a perfect square. So when there's a perfect square, we know that our middle term is 2 times by something, or we can also just do that maths eventually later. So let's go with that there. I'm going to leave a gap as we did earlier so that I can sort out that other part. And then I'm going to leave another gap here. So the value that we're going to add here is going to be, no, I'm going to do it there. So the value that's going to go there is going to be related to this x term. So we know that it's going to be -4 on 3 all divided by 2 squared. So that's going to turn into -4 on 6 squared, which is going to turn into -2 on 3 squared. Now we're going to leave it as this -2 on 3 because that's going to contribute to us knowing what our actual perfect square factor is going to look like. So we're going to add that -2 on 3 squared, and then we're going to take it -2 on 3 squared over here. We do want to make sure that we are including that negative inside of there just because in this first portion of our equation, we know that we need to make sure that that is actually a perfect square. So if I was looking at this, which I actually did earlier, and I just used that as +2 on 3, then you're going to start making some little mistakes like saying that it's actually x squared plus 2 on 3, or sorry, x plus 2 on 3 in squared. Now, before I do that, I'm just going to preface that I'm using a big square bracket here because inside of this big square brackets, I need to make my x take h squared and my k inside of that. So first of all, let's look at this big green part here. So x take 2 on 3 squared. That's my x take h squared part. And then to that, I'm going to add all of this over here, which is quite a tricky one because if we have our calculator, no dramas, but you want to make sure you get this part right. So I'm going to do that on the right hand side, just in a different color. So 1/3 take -2 on 3 squared. That's going to give me 1/3 take +4 on 9 because we square each of those separately. And then I'm going to have to make sure I've got the same denominators. So 3 on 9 take 4 on 9. And then that gives me -1/9. So that's what my final part is going to be, -1 on 9. Now, if you had to graph 1 on 9 or a ninth, that's pretty tricky. But remember, we're going to times everything through by this +3. So I get 3 times x take 2 on 3 all squared, take 3 on 9, which is actually just 1/3. Bit easier to graph, so it's not too crazy. Just when it comes to that, we make sure that we just leave the 3 out the front of the x. We do not times it by inside of the brackets to get like 3x take 2, because that is going to muck things up. Now we're going to look at our sort of stock take. What do we have here? So looking at our nice y equals down here, this is our new vertex form thing. We have got +a. So +a means a smiley face. Beautiful. Second thing we're going to look at is our vertex coordinates, which is h and k. We have x take h. So that means h is equal to +2 on 3. And we have take 1/3, which means we have -1 on 3 as our vertex. We know that the axis of symmetry is just our x coordinate of that vertex because it's already telling us our maximum or minimum. So from here, we're going to draw it. One thing I did forget actually is our y-intercept. So y-intercept occurs at x equals 0. X equals 0 when we have 3 times by -2 on 3 squared, take 1/3. So 3 times by 4 on 9. So that is going to turn into 12 on 9. And then we take 1/3 of that. So we take 3 on 9 away. That actually becomes 9 on 9, which is just +1. So that's actually quite nice. Let's put in the things we know. So vertex, 2 on 3 and -1 on 3. So let's zoom in on our graph. So let's say that this is 2 on 3 and that's -1 on 3. So if that was 1/3, that means that our +1 is probably going to be somewhere up here. Our axis of symmetry is here, and we go ahead and we draw. So not the best diagram, but it shows us the important things, which are 2 on 3, -1 on 3. We've got our intercept at y equals 1, and we've got our axis of symmetry, which you can also write in if you want to at x equals 2 on 3. Now that's a tricky question, as I said. It's definitely up there with the A-band stuff, but it is definitely good to see the different ways that they can be presented to you.